Tutorial 3. Entering the AnchorWall Software version 6.0 design interface and defining the design parameters. You are now in the Design Interface screen. The tabs along the top of the screen are organized chronologically with the design process in mind. The Design Criteria tab is automatically selected. The user can either select conventional analysis or reinforced analysis to see the relevant design criteria. Sub-tab 1 is Design Notes, which provide brief commentary about the design methodology chosen. Sub-tab 2 is Empirical Checks. These are empirical minimum or maximum values for such elements as wall embedment depth, reinforcement length, base to height ratio, anchorage length, and geogrid separation. Sub-tab 3 is Factors of Safety. The user can select either static or seismic to show the various minimum factors of safety for a given mode of failure. If the AASHTO LRFD design methodology is chosen, this area would display load and resistance factors. Sub-tab 4, Design Inputs. This final category of design criteria includes some remaining design constants and variables that are applicable only to the AASHTO methodology and therefore remain blank when running NCMA. For each sub-tab, the default value is stated in the chosen design methodology. The user has the option of modifying the used value, keeping in mind that any changes that differ from the default will be at their own risk. We will now move on to the Wall Unit tab. The Wall Unit tab allows the user to select the anchor wall system to be used in their design. On this project, we will select the Diamond Pro system. All unit properties such as the dimensions, mass, batter, shear capacity, and maximum allowable vertical geogrid separation are displayed. Note that an additional field has been included called hollow core %. This variable indicates the percentage of the block mass that is filled with free draining aggregate and will be included in the quarterly estimate as part of the drainage aggregate calculation. In the wall unit screen, the properties of the block cannot be modified. These properties have been input by AnchorWall systems and are uneditable. At the bottom of the Wall Unit tab, we have the option of inputting the size of the granular base for the wall. Simply input the base extent or distance the base extends out in front and behind the block and the base thickness. This is only used for quantity calculations and bearing capacity calculations for conventional walls. Now we will move to the next tab, Reinforcement. The Reinforcement tab allows the user to select a reinforcement supplier from a list of industry-leading geosynthetic reinforcement suppliers that have connection testing with the anchor retaining wall systems. The suppliers drop-down menu will show all reinforcement suppliers that have connection testing results with the block that has been selected. Therefore, the available geogrids listed in the supplier's drop-down menu will change depending on the block that has been chosen. Note that the selected block is shown at the top of the reinforcement screen. The AnchorWall software system manages this information and organizes it automatically for the designer. We then select a geosynthetic in the Available Products table on the left and move it into the Used in this wall table on the right using the right arrow. Note that you can have unlimited different geosynthetics available in your design from any supplier. For this example, we will use 2 strengths of geogrid. The geogrid properties are shown. These have been provided by the geosynthetic supplier. We now have to select the type of soils that will be used in the reinforcement zone from the drop-down menu in Geosynthetic Properties. In this example, we will be using well-graded sandy gravels. The selection of the soil type determines the installation damage factor, or RFID, the coefficient of direct sliding, or CDS, and the coefficient of interaction, or CI. Below this, the block grid connection properties are provided for the selected block and grid. Again, these values cannot be edited on this screen or in the connection properties maintenance screen as they have been supplied by AnchorWall systems. Beneath the connection properties is the shear with reinforcement data. This is the block-to-block shear with the inclusion of a reinforcement layer. We will now move to the 4th tab, Site Conditions. In the Site Conditions tab, we will define the soil conditions used in the design of the wall. Some default soil types and values have been provided for the reinforced, retained, leveling pad, and foundation zones of the wall. Different soil types and values can be selected from the drop-down menus. The soil parameters listed for each soil are designated according to the Unified Soil Classification System and include typical friction angle and unit weight values that can be used for preliminary analysis. All of these soil parameters are editable in the Site Conditions tab. If you are consistently using a certain combination of soil types and parameters, you can easily set your defaults to whatever values you wish in the Soils Maintenance screen under the Settings menu. To illustrate this, we will go to the Settings menu and select Soils. The Soil Maintenance dialog box pops up. Here you can change the parameters of the existing soil types or add new soil types. Finally, the Set Soil Defaults button allows you to do just this for each of the soil zones. By hitting Save, we save all changes made to the soil types, parameters, and/or defaults. We will now close the Soil Maintenance screen and return to the Site Conditions tab. Keep in mind that any parameters set in the Settings menu are global parameters and will be available for any future project. Within each individual project, any edits or changes made are local to that project and will be saved only as part of that project. Below the Soil Parameters area, we have included a feature to allow for the quantity calculation of various different drainage layers in the wall. It is important to note that all analysis assumes the wall is fully drained and no hydrostatic pressure is present. The drainage dialog just allows the designer to include a different drainage material for quantity calculation and illustration purposes only. For example, if my reinforced zone is not free draining, I would want to include drainage zones at different locations within the reinforced zone, depending on the anticipated groundwater levels and/or surface drainage. By selecting Include Drainage, the drainage fields becomes editable. Values are listed for friction angle and unit weight for the drainage material. However, they are not used in the calculation. 3 different types of drainage layers are available, which includes a face drain, a blanket drain, for reinforced walls only, and chimney drain, also for reinforced walls only. The face drain is immediately behind the wall units, and although it is referred to as a drain, it is mainly used for ensuring compaction into this area. We can now set the thickness or front-to-back depth of the drain. A minimum of 12 inches is recommended by the NCMA. We can also set the depth of the impervious cap at the top of the face drain. The top of the wall should always be capped off to avoid water from infiltrating into the face drain from above. A swale should be used to carry surface water away in accordance to recommendations provided by the NCMA Design Manual. You can set the thickness or depth of the impervious cap here. At the bottom of the face drain, we can indicate that we want the face drain to terminate either at grade, which would mean you would be outletting through the face of the wall, or at base, which would mean you are outletting to a positive outlet, such as a catch basin with an invert below the base of wall elevation. The NCMA recommends that if the high groundwater level is anticipated to be within 2/3 of the height of the wall to the bottom, a blanket drain should be included. This is a drain that runs along the bottom of the reinforced zone to collect water coming from below. Again, a thickness can be set. Finally, if groundwater is anticipated up to a certain elevation above the base of the wall, a chimney drain should also be included to capture water flow from behind. In some cases, the anticipated maximum groundwater elevation is provided by the geotechnical engineer as a given elevation. For example, the maximum groundwater level has been estimated to be at elevation 106 feet, or 106 feet above sea level. As the wall grades may rise above or below this at various points, we felt it would be beneficial to be able to set the top elevation of the chimney drain to a certain elevation and let the AnchorWall software figure out how high the chimney drain extends in any given panel. We will see this demonstrated later when we look at the cross sections, but essentially, depending on the founding elevation of a given panel, one panel may have 5 feet of chimney drain and another could have 10 feet. We will set our top chimney drain elevation, making it 1 foot above the high groundwater level. The various drainage layers will be shown graphically and will be included in the quantity calculations. We will now move on to the Extreme Events tab. Included in the Extreme Events tab is seismic loading. AnchorWall Software also gives the user the option of including barrier impact loading, which is another extreme event. However, this option is found in the Loading tab, as the user may want to just apply the barrier loading to specific panels and not globally to the entire wall. The barrier impact loading is only applicable to AASHTO analysis. By selecting Include Seismic Analysis, AnchorWall Software automatically runs both seismic and static analysis simultaneously, and the results for both are displayed. We will input the peak ground acceleration value, or PGA. Next, the user can decide to allow the deflection criteria in the seismic analysis and set the allowable wall deflection to either the default of 3 inches or set their own. Below this, the user has 2 remaining options for the seismic analysis. These options are only applicable to AASHTO analysis, but we will discuss them briefly. First, the user can choose the option of either including or ignoring face batter in the calculation of the weight of the internal wedge for seismic internal stability analysis. If it is on, the calculation of WA will account for the fact that the wall batter reduces the total area of the wedge, and therefore reduces the weight, thereby lowering the applied loads in the geogrids for internal stability calculations. If it is left off, the user is being more conservative, and the wedge is assumed to have a vertical face and therefore will be a larger area in weight. Finally, the user is given the option of including live loads in the seismic analysis, in case some specific circumstances warrant this. Now that we have set all of our system design parameters, we can look at the actual wall we are going to design. We will move on to the Stations tab to define the wall layout geometry in the next tutorial, tutorial number 4.